back to my channel. Today I'm going to be talking about sequences, okay? So a sequence. And with a sequence, let's say AN, okay? So we want to know if the sequence converges or diverges. And to do this, we have to look at the limit. So we evaluate the limit as n goes to infinity for AN. So if this limit exists, so let's say it's a finite number, right? Then that means that this sequence converges. So it'll be convergence, right? And if this limit, let's say it doesn't exist, okay? Doesn't exist, does not exist, that's short form DNE, then that means the sequence diverges. So the sequence diverges. Okay? And keep in mind that we are finding the convergence and divergence of a sequence, so not a series. Series is like you add the numbers together. The sequence is different, okay? So it's like a list of numbers. So that means it's different in the series. So say we have a sequence that looks something like this, and we want to determine as to whether it converges or diverges. So to do this, we evaluate the limit as n goes to infinity for this. So the limit of this, right, this is our AN, so we're going to plug that in. As n goes to infinity, well, this means that this n squared is going to go to infinity as well, right? And this is infinity, and it's going to get a really big denominator. Now we have a really big denominator in comparison to a really tiny 7 in comparison, right? Tiny 7, big denominator basically shrinks this number. So then this limit is going to approach 0 then, because this is getting really small, it's getting really big, so it's like the number's getting really small, so 0. Okay, now here we get 0, and that's a finite number, right? And the limit as n goes to infinity of AN basically is equal to 0, and it exists, right? So this exists. So this here, limit n goes to infinity, AN exists, right? So since this is the case, then therefore the sequence converges. Looking at another example here, we will do the same thing. So we're going to find a limit as n approaches to infinity for AN. And we are going to evaluate this. So plugging this AN in, 2n plus 5 over 6n plus 7. So, okay, well, we're going to have to evaluate the limit of this, and we plug in infinity and infinity. It's just going to make the top and the bottom go to infinity. Okay, well now it's like infinity over infinity. Not very great, so we have to use L'Hopital's rule. So using L'Hopital's rule, we have to differentiate the bottom and the top, right? Top and bottom. So we're going to find the derivative of that. And the derivative of 2n plus 5 is just going to be 2. Derivative of 6n plus 7 is going to be 6, right? We use the power rule for derivatives, right? This is going to be 2 to the exponent of 1, this is exponent of 1. Then we take the 1 down and then subtract 1 from the exponent, which is going to give us n to the exponent of 0, right? So it's just going to be n to the exponent of 0 is equal to 1, so it's going to be 1, right? So then it's just going to be 2 over 6 here. Okay, because it's like we just multiply 2 times 1. 6 times 1, and these are constants, so the derivative of that's just going to be 0, so we're adding 0 at the end here. So yeah, so we found the derivative of that, it's going to be 2 over 6, and 2 over 6 is the same as 1 over 3, and then n goes to infinity. Well, there's no n here, so this ultimately is just going to go to 1 over 3 then. And there we have it. And hey, look, the limit exists, right? The limit exists, so here we have this exists. So since this exists, and therefore AN converges. Then we have a sequence that looks like this, and we're trying to find as to whether it converges or diverges. So we find the limit of that. So limit this as n goes to infinity. N squared plus 1 over n. So to do this, we can see that evidently if we take the limit, so if we take the limit and we divide by the highest power, right, n squared, we divide all these terms by n squared, right, that's how we evaluate the limit. N squared over n squared, right, this n squared, and 1 divided by n squared, and this n divided by n squared, right, so n squared plus 1 and over n, all these divided by n squared. And now we look at it and we see, okay, well, this is 1, right? N squared over n squared is going to be 1, so you cancel them out. And then this is 1 over n squared and then over n squared. Now in this case, this n squared is going to be a really big denominator in comparison to tiny 1. So that means that it's going to shrink this number. So that number right here is going to go to 0. So 1 plus is going to be 0. And then here, n over n squared. N squared is bigger than n. In comparison, it's going to go to infinity faster than n. So this is going to just approach 0. Hey, look, we get like 1 over 0, which means the limit does not exist, right? So it's going to go to infinity, so limit does not exist. So that means the limit does not exist. And since it does not exist, then that means our sequence diverges. And that's it. Okay, so this is the end of the video. If you enjoyed this video, feel free to give it a big thumbs up and also let me know in the comments down below what you think about it. And furthermore, if you are new to my channel, feel free to hit the subscribe button if you enjoy my content. Thank you so much for joining me today for a math video. I hope to see you next time. Bye!